So let's discuss a problem based on clutches, right? So the problem that I'm going to discuss today is based on a single plate clutch, right? So now this is how they give us the problem, right? So the problem is we need to calculate the power, right, transmitted by the clutch, at 3000 RPM, right? And one consideration is given, right? So that is, consider the clutch is an old clutch, or the clutch is old, right? So that is the consideration, right? So that means this is how actually in competitive examinations, right, we are going to get the questions, right? So that means now the clutch is an old clutch, so that means we have to consider, that means we must consider the constant wear, right, theory. That means we need to consider the constant wear theory, right? All right. So now we need to calculate the power transmitted at 3000 RPM, right? And now these are the given data, right? Given data, right? Outer diameter of the clutch plate is given, right? Then inner diameter of the clutch plate is also given, right? So what is that? 400 millimeters, right? 300 millimeters. Then the coefficient of friction, right? Coefficient of friction mu is given as 0.35, and the other most important factor, what is that? The other most important factor is that maximum intensity of pressure at any point in the contact surface, right, cannot exceed 0.09 newtons per millimeter square, or in other words we can say megapascal, right? So that is another given information, right? Well, so now let's calculate. So what is the very first thing that we can calculate? So now this is the very first consideration, right? Be very careful. Now these are the logics that you need to write, right? The intensity, right? Please practice these things, right? The intensity of pressure is maximum at the inner radius, right? So that is the first point, right? The intensity of the pressure is maximum at the inner radius, right? So there we have a, so there actually we are going to use a special equation, right? So that is C, right? So let's call this C constant, right? Equals, right? P times R2, all right? So now what is P, right? So that is what we are going to consider as maximum intensity of pressure, right? So which is 0.09 newtons per millimeter square multiplied by, now what is the, now we are given the inner diameter of the clutch plate, so that is what, 300 millimeters. So then what is the inner radius? That is the half of 300, which means 150 millimeter. So if you carefully do the calculation, right, so then you will be obtaining 13.5 newtons per millimeter, right? So this is one part, right? The next thing, what is the next thing we need to calculate? Now we need to calculate the axial thrust, right? The next thing is the axial thrust. So now you need to remember the equation. So what is the equation for the axial thrust? 2 pi times, right, this constant C, right? Then the difference between the outer radius and the inner radius, the axial thrust. So then 2 pi, then 13.5, this C value. The outer diameter is 400 millimeters, so the outer radius is 200. 200 minus 300 means 150, right? So this part will come in millimeters, right? So be very careful about the units, right? So anyhow, the final answer will come in newtons, right? Be very careful about the units. The final answer will come in newtons. What is that? 4241.50. So this is another part that you need to calculate. So now the other thing that we need to consider is the mean radius, right? So now mean radius, right? Considering what? Mean radius, considering the constant wear, right? What is that? Let's call it capital R, right? R1, simple R1 plus simple R2 divided by 2, right? Mean radius. So what is that? 200 plus 150 divided by 2. The answer will be 175 millimeters, right? 175 millimeters, right? Now, what is the next thing that we need to calculate? So I will go to here, right? So now we need to calculate the torque transmitted, right? Torque transmitted. So now there also, that's a very important equation that you need to remember. What is the equation for the torque transmitted? So that is simple n times, what is simple n? The number of effective sites, right? Simple n times, right? Mu, right? Simple n times mu, right? The coefficient of friction, right? Then axial thrust times the mean radius. Again, simple n times the number of effective sites, right? Then coefficient of friction times the axial thrust times the mean radius. So now here in this question they have not specified about the number of effective sites, right? So let's say that, so let's consider, as it is not given, right? So sometime in the problem they might give that, consider that both the sides are effective, right? So that means, what is that simple n? That equals 2, alright? So 2 multiplied by 0.35 multiplied by the axial thrust, the one we have calculated here, 4,241.15, alright? Times, now here this is a constant, a certain number, then a number, the one that is in the axial thrust, which is in newtons. So better if you put the value of the mean radius in meters, right? So then you can directly obtain the answer in Newton meters. So we know the mean radius is 175 millimeters. So better write it as 0.175 in meters, right? So then you will obtain the torque transmitted as 519.54. 519.54. So then what is the power? The last part. What is the power? The power transmitted at 3000 RPM will be the torque transmitted times the angular velocity, omega. So what is the torque? 519.54. RPM is given 3000 revolutions per minute. So multiply by, because one revolution contains 2 pi in radians. So 3000 multiplied by 2 pi divided by 60. Right? So then what is the final answer? So final answer in kilowatts, right? Final answer in kilowatts will be 163.218. 163.218, right? So this is how you should solve this type of a problem. And good luck for your examination.